Hello, good to have you back with us on this fine day. What we're doing today is 7.2, adding and subtracting polynomials. So what we're going to start off with is addition. And I want to be very, very clear about how simple adding and subtracting polynomials can be. When we have addition between two polynomials, I'm basically just going to ignore all of these parentheses. I have a long string of different monomials, 3a squared plus 8, positive 5a, negative 1. And what I want to do is essentially just combine all of the like terms. And that will be me adding these two polynomials together. Okay, it doesn't need to be any more complicated than that. So why don't I first start off by trying to find any like terms. I have 3a squared here. Circle that one in blue. Are there any other a squareds? No. Let's see. I have a singular constant 8. Are there any other constants? Yes, there are. And I'm not even going to bother with the last one because there's just one term left, 5a. So let's rewrite this by combining all the like terms, keeping it in descending order, because that's the correct format. So 3a squared, that's my highest degree. When I combine positive 8 and negative 1, I'm going to get positive 7 and plus 5a. Okay, so right now I've just combined all the like terms. I don't have it in descending order. 3a squared is still my highest degree. My next highest degree is positive 5a. And my last highest degree is the constant plus 7. Okay, so it doesn't need to be any more complicated than just combine like terms. So let's try out B. Let's see how easy it can be. This time I'm not going to do any circling. I'm just going to look for my highest degree in here, which looks like it's x squareds. And it looks like I have two of them. I have one here, and I have one here. So remember, this is a negative 1 x squared, and this is a 3x squared. When I combine the two, it's basically saying 3 minus 1, which gives me a positive 2x squared. Now I look for my next highest degree. Those are going to be anything that says x. So I have a 5x right here, and I have a negative 8x over here. Now I need to combine them. I have 5 and negative 8. What does that get me? Negative 3x. And lastly, in both terms, I have a constant. I have a constant of positive 4 here. I have a constant of positive 9 here. Okay, that's a little bit more clear once I say I've used this one, I've used this one, I used the 5x, I used the negative 8x. The only thing that's left is the constant 4 in the first trinomial and the constant 9 in the second trinomial. When I add 4 and 9 together, I get a positive 13. So I have all like terms combined. X squared, x constant, yes. Is it in descending order? X squared, x to the first, x to the 0 technically. So we are good. This is simplified. I have added the polynomials together. Alright, just like with integers, when I move into subtraction from one polynomial to another one, it's essentially the same thing as adding the opposite. Okay, if I want to do something like 5 minus 3, that is the same thing as 5 plus negative 3. It's adding the opposite of this number. 5 minus 3, 5 plus negative 3. So that's what I'm going to do when I subtract. Now again, it doesn't need to be any more complicated than combining like terms, but with subtraction I need to make sure that when I am doing the addition and combining all the like terms, that I'm combining the correct like terms. So just like we had to change this number here to be a negative 3 and add them, I'm going to do the same thing to this polynomial here. And stick with me and try and follow along here. This is going to be y squared plus 4y plus 2. The first polynomial doesn't change. Now the next one, I'm basically just going to apply this negative to every single one of the terms and change their signs. So this is, right now, a positive 2y squared. I'm going to make that negative 2y squared to signify that I'm subtracting it. Now I also have to apply it to this one. Because this negative is on the outside of the entire polynomial, it has to get applied to every part of it. So instead of this being negative 5y, it's actually going to be plus 5y. And instead of this being a negative 3, when I apply the negative to the entire polynomial, it becomes plus 3. Now again, it's just like I had an addition problem. And all I have to do is combine like terms. I have y squareds here and here. One of them is a negative 2y squared. The other one is positive 1. When I combine positive 1 and negative 2, I get negative 1. And those are y squareds. So that's been used, and that's been used. The next thing I'm looking at are the y's. I have positive 4y and positive 5y. When I combine the two, I get positive 9y. Awesome, that's been used, and that's been used. And all I'm left with is just the constants. Positive 2 and positive 3. Add the two together, positive 5. I have one trinomial here, 3 terms. I have it in descending order, y squared, y to the first, y to the 0. And it looks like there's no other like terms that I can combine. So this one is finished. Let's do example B. And if there was any sort of confusion on A, let's hopefully clear that up on B. So the first thing I'm going to do, I notice I have subtraction. So this subtraction sign has to get applied to every part of the following polynomial. So when I rewrite this, the first one doesn't change. 5x squared plus 4x minus 1. But the second one, every sign is going to change. Minus 2x squared plus 6. And now it's just like an addition problem. All I'm going to do is just combine like terms. I forget about all the parentheses. I just look for what I can combine. And I have 5x squared. If I look at my highest degree first, I have negative 2x squared. And when I combine those two things, 5 and negative 2, I get 3 of the x squareds. I have positive 4. I'm going to cross these out so I don't try to use them again. I have positive 4x and nothing. Looks like 4x is the only one of those terms. So I'm just going to go ahead and bring it down. There's nothing to combine it with. And then lastly, I have negative 1 and I have a positive 6. When I combine those two things together, I get positive 5. Here is my resulting trinomial. All in descending order, x squared, x to the first, x 0. No other like terms to combine, so that is my solution. Right? If you need to, go back to the beginning, follow along with me again, clear up any sort of questions that you have in your mind before trying example 3 on your own. Okay? It's an addition problem, so you basically can just forget about the parentheses and combine like terms. And you have a couple of possibilities here, A, B, C, or D. When you're all set with that, we'll move on to example 4, and I will check for example 3 in class. Alright, example 4, again, the last one in these is always some sort of application problem. So what it looks like we have going on is somebody at the highest point in the building throwing a penny straight down from 200 feet. But at the same time, there's, I don't know, maybe these people are friends. Maybe there's some sort of rich backstory between the two. I honestly, I can't speak to that. I don't know. But it seems like they're quite strange, and they enjoy throwing things out of buildings. And personally, I don't condone it. I don't want you to go ahead and do this. I'm getting off on a tangent, but it's fine. It's fine. Anywho, what we have is an equation up at the top that represents the penny falling. We have an equation at the bottom that represents the paintbrush falling. And what I want to do is write an equation that will represent the distance between these two objects as they fall. which at first probably seems crazy or extremely difficult. But if I told you that something is, or a person in class is 5 feet tall, and another person in class is 3 feet tall. Hopefully I think you're all taller than 3 feet right now. And we wanted to figure out the difference between their heights. You would tell me that I need to subtract. And I would say 5 minus 3, and there's a difference of 2 feet. So why is it any different when I tell you that there's an equation that represents this height, there's an equation that represents this height, and I want to know the difference between the two? Well, it's not any different. I'm going to take the first, negative 16t squared minus 40t plus 200, and I'm going to subtract the second polynomial from it, minus negative 16t squared plus 100. Okay, now it's a subtraction problem, so right off the bat you should be thinking, this negative sign is going to cause me to do a little something. I got to apply it to both of the terms that follow. Alright, so the first one, not going to change at all. Negative 16t squareds minus 40t plus 200. But my second polynomial will change. This one, instead of being a negative t squared, is going to switch sign. It's going to be a plus 16t squared. And this one, instead of being plus 100, will now become minus 100. Now I have one straight long expression that I need to simplify. I need to combine like terms. I have a negative 16t squared, and I have a positive 16t squared. Awesome. When I combine those two things, what do they equal? 0. So I don't even need to write that in my equation. The next one I'm going to go to, I'm just going to cross these out, is the negative 40t. Is there any other part of this equation that involves t? No. Negative 40t is all alone, used. And now positive 200, negative 100. When I combine those two things, positive 100. Awesome. So what is this representing again? I just did a whole bunch of math and I forgot. It is representing the distance between these two objects at any point in time. Right? This is some function of t, function of time, that's going to tell me I can put in any time and I'll have the distance between the two objects. Well, that's, quite impressive, seeing as how part B is asking what is the distance between the objects after 2 seconds. Alright, so fortunately, in part A, we actually got an equation for that. I know that at any time, this will tell me the height of, or the distance between the two objects. So it wants it at 2 seconds? Yeah, sure, no problem. I can evaluate this function at 2 seconds. All I'm going to do is substitute a 2. What is negative 40 times 2? Hopefully that's easy for all of you. Negative 80 plus 100. So f of 2, running out of room, but luckily this is the end, equals 20. And what units are we using here? Are we using feet? Feet. That is the distance between these two objects after 2 seconds that they've been dropped. Alright, if you are having any trouble with example 4, please rewind, go back and check it out again. Hopefully it can clear up any of your questions. If you still have some remaining, write them down. We'll talk about it in class. And so long!